Constraints help us to manage both the quality and integrity of the data that's in our tables. The data type for each column is a type of constraint, and we've learnt about primary keys and foreign keys, which are also types of constraints. In addition to these, there are several other constraints that we can use. In this video, we'll be looking at check, unique, and not null constraints, and also how to use what are called default values. Check constraints allow you to provide a Boolean expression which must evaluate to true for a table insertion to occur. So looking at our users table, for example, where we collect email addresses, you could use a check constraint to perform some additional validation of that email to ensure that it looks like a valid email address. You don't want to go too overboard with this, but there's a couple of basic checks that we can do. Let's add a check constraint now for the email address to ensure that its length is at least 3, there's at least 3 characters, and it contains the @ symbol. So we can specify this after the column name. We first write check, and in brackets we now specify the Boolean condition that must be true in order for an insertion to take place. In this case, we want the length of the email to be at least 3 characters, and we want the @ symbol to be somewhere in the text. To perform that check for the @ symbol, we can use the position function. And we'll say the position of the @ symbol in the email must be greater than 0. The position function returns the index of that @ symbol within the email. If you're unsure about that use of the position function, feel free to write a couple of queries just to play around with it. For example, we could pull it down here and we could say select position @ in, and just specify something to test that it behaves as you expect. So we'll write hello, and if we run this, you get 1. And if the text itself doesn't contain the @ symbol, then you get 0. Let's imagine now a scenario where there are only 3 valid tags that are able to be used. Let's call them work, personal, and to do. So we want to add a check constraint to the note tags table to ensure that you can only insert one of those 3 values, work, personal, or to do. So we can write a check constraint to do that. And the way you would write this one is you look for the tag being in. If you remember, we've looked at the keyword in the past. In one of the 3 of work, personal, or to do. We'll close that out. And now that's our check constraint on the tag. If you insert a new tag, the tag must be either work, personal, or to do. In the last 2 examples, we've added the check constraint after the column definition. But what if you wanted your check constraint to reference several columns in the table? You can do that, you just have to swap from now using that column constraint syntax to using the table constraint syntax. To demonstrate this, let's imagine a scenario where for each note we want to capture a create date, so the date that the note was created, and also a last edit date, when it was last modified. Let's add 2 columns to the notes table to track that. So we'll add the create, and we'll make it a timestamp of type timestamp TZ. That's short for timestamp with time zone. Let's also store the last edit timestamp. And also we'll make that a timestamp TZ. What we'd like to do now is create a check constraint that references both columns and makes sure that the last edit timestamp is always greater than or equal to the create timestamp. It wouldn't make sense to allow people to ever specify an edit date that's before the creation date. That just doesn't make sense. So we'll add a check constraint that the last edit timestamp is always greater than or equal to the create timestamp. And if I wanted to name this constraint, I would start this line with constraint and then the name of the constraint. So I might call this check_ts, but I don't want to do that here. I'm quite happy with whatever the database chooses as the name for this check constraint. While I'm here, it would also make sense not to require people working with my tables to always have to provide the create date and the edit date when inserting a row. So what I can do is add some default values for the create timestamp and the last edit timestamp. And when I do that, anybody who then creates an insert statement for the notes table doesn't have to provide values for those 2 columns. They'll automatically get the default value that I want them to get. So if you create a new row in the notes table, I want the create date to have a default value of now. Now is a function that returns a timestamp that corresponds to the current time. So I want that for the create date, and I also want that for the last edit date. Because at creation time, the last edit timestamp is actually the creation timestamp. Let's look for any other places where I may want to set a default value for my 3 tables. In my users table, I've got email, first name, last name, and an isActive boolean. IsActive just keeps track of whether that user is active within our system, so it would make sense that when you create a user account, you would want that user to be set as active. So we can set a default value for this column of true. So we've added some check constraints to our tables and default values. And related to default values, I can also specify that I don't ever want a column to be able to contain null. You should be quite liberal about using this. As we've seen throughout this course many times now, handling null can be quite tricky. When you know that a column can't contain null, that makes your life a whole lot easier when it comes later to writing correct queries. So looking at the users table, I think it's okay that the first name and last name could be null. We may not ever capture that from a user, but I think it would always make sense that isActive never contain null. So we can add in the constraint, not null. You can add multiple constraints to a column, as I've done here now, so isActive contains both a not null constraint and a default value. That's fine, and the order doesn't matter, by the way. Looking at our notes table, it probably doesn't make sense to allow people to insert a null note. So let's set the note column to be not null as well. And finally, looking at the note tags table, I don't think it really makes sense to allow people to insert a null tag either. So let's also set that column to be not null. So we've now added check constraints, we've added some not null constraints, and we've set some default values for columns where it made sense. We're almost done here. The very last thing we might want to do is add some uniqueness constraints. A uniqueness constraint guarantees that the values in a column, or a combination of values if you specify more than one column, are unique. Just for demonstration purposes, let's say that we wanted to start capturing a title for each note. So each note has both a title and text. Let's add a new title column. That type is of text. We probably want it to be not null because we would always like a title. And now let's add this one final constraint, which is the uniqueness constraint. By adding a unique constraint to the title column, what that means is no 2 notes can have the same title. Okay, so I'm pretty happy with my 3 tables now, and let's populate them with some data to see these constraints in action. What I'll do is I'll select all of these create statements and the create schema and the drop schema statement, and I'll run all of these commands now. So on running this, it's going to drop the schema, it's going to create it again, and then it's going to create all these tables within that schema. Okay, so that's worked. Let's go ahead and insert a new user. I'll bring up my insert statement up closer to the table definition, just so we can reference it as we talk about it. So for each user, we capture an email address, first name, last name, and then an isActive flag. Because isActive now has a default value, I don't have to specify it when I'm performing the insert. So I can remove that, and if I run this, I should have now one user in the table. And you can see that isActive is set to true, so the default value has worked. Also, if I now try to insert an invalid email address, so let's just try test so it doesn't contain the @ symbol, I get an error, and the error is that this new row violates the check constraint. Moving on to the notes table, let's insert a new note. I'll copy this insertion statement up next to the definition. And each note now consists of a title, a note, a create timestamp, and an edit timestamp. Create and edit have a default value, so I don't have to specify them when performing the insertion, but I do need to provide a title. I'll make this title the to-do list. Let's run this insert statement, and now let's run a select against that same table. And we can see that we have a create and an edit timestamp that corresponds to the current time. That's the default value calling the function now in action. We've also got a unique constraint defined on the title. So if I tried to insert another note now that had the same title, the to-do list, I'll get an error. I'll change the note itself just to something else, and if I now run this, I get an error that says duplicate key value violates the unique constraint, and it says the to-do list as a title already exists. So that's our unique constraint in action. In this video, we've now seen in action check, unique, and not null constraints, and how to specify a default value for a column. And earlier, we learned about primary keys and foreign keys also as types of constraints. Altogether, we can use each of these types of constraints to help ensure that we only permit valid and well-formed data into our tables.